Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions of DME chapter Keith Williams Radio Nav. So far I have answered 50 questions. In this video lecture, I am going to continue answering the next question. So let's start with question number 51. How can a DME interrogator distinguish between its own reply pulses and the reply pulses of other aircraft in the area using the same DME station? So it's very important question, uh, especially for ATPL. So this question came many times before. So this is often repeated question. So now there are two scenarios. The first scenario is that DME equipment in your aircraft is able to distinguish is able is is able to distinguish between its own reply pulses and pulses which are ground reflections, which are ground reflections. In second scenario, DME equipment in your aircraft is also able to distinguish between the reply pulses intended for itself and reply pulses intended for other aircraft. Okay, so these are the two ways how DME equipment on board is able to distinguish between ground return, okay, and also the reply pulses which is not made for itself, which is not intended for itself but for some other aircraft. Now scenario 1, this scenario is addressed in what manner? Now the DME equipment in such a case, we all know, works on the basis of secondary radar, okay, and secondary radar operates on the principle two different frequencies, one for interrogation and another for reception. So in case of DME, let's say there is this aircraft in the atmosphere, right? This aircraft will transmit this aircraft will transmit radio pulses in the direction, okay, in all directions, omnidirections, and this radio pulses will be received by the ground DMA station. It will wait for 50 microseconds and after that it will retransmit radar pulses in all directions, omnidirections, and this radar pulses will be received by your aircraft DME receiver, right? So this is how, and then after calculating the time that it has taken for this radar pulse to go and come back, and multiplying that by ground speed or the speed correction, the speed of the radio wave, 3 into 10 raised to 8 meter per second, you can calculate slant range. This is how the DME equipment is able to show its slant range to us. So this is how the this is how the DME system works. The interrogation frequency at which aircraft sends or transmits interrogation pulses to the ground station is at 1090 megahertz, and it receives them back at a different frequency of 1030 megahertz. Okay, so this is how it is able to distinguish or tell the difference between a ground reflected pulse and a pulse coming back from the DME station. The ground reflected pulse will be at the same frequency as that of the transmission, which is 1090. In case of DME reflected pulse, the frequency will be different, 1030 megahertz. So this is how it differentiates between ground returns and DME pulses. Now in the second scenario here, this one, how it is able to identify its own pulses and disregard or reject pulses intended for other aircraft. So it happens this way. The time interval between consecutive pulses is varied. Okay, is varied. This is called jittering. This is called jittering. So let's say here is aircraft number one. Here is aircraft number one. Okay, and here is aircraft number two. Here is aircraft number two. Okay, so this aircraft number one transmits, let's say, this pulse pairs to a DME station, and the difference of time between this pulse pair is 5 seconds, for example. Aircraft number two, on the other hand, sends its own unique pulse pairs in the direction of the DME station, and the time interval between this pulse pairs is 10 seconds. Okay, so this is how the pulse pairs the time interval between different pulse pairs are varied for different aircraft. So every aircraft will have its own time interval, will have its own unique pulse pair. So this aircraft number one will only accept those reply pulses coming from the DME station whose time interval is equal to 5 seconds. It will reject all other pulse pairs whose time interval is any different from 5 seconds. Aircraft number two in this case will only accept those pulse pairs which are at a time interval of 10 seconds and reject those pulses which are not at this time interval. So this is how it is able to identify between its own pulse pairs and disregard any other pulse pairs which are irrelevant. So the correct option here will be the pulse repetition frequency of the pulse pairs transmitted by the interrogator varies. For each interrogator there is a unique rhythm. Yes. On Y channel, the time interval between the pulses is 36 meter per second and incorrect. DMA transponder uses a slightly different randomly varying delay for each interrogating aircraft. No. The delay is fixed at 50 microseconds for every aircraft. The time interval between both pulses of consecutive pulse pairs is transmitted by the interrogator varies. For each interrogator, there is a unique rhythm. Okay. So the correct option here will be option delta. The time interval between both pulses of consecutive pulse pairs transmitted by the interrogation varies. For each interrogator, there is a unique rhythm. Okay. The pulse repetition frequency of the pulse pairs transmitted varies for each interrogator. There is a unique rhythm. On the Y channel, the time interval between the pulses and of transponder is so and so. The DME transponder uses a slightly different varying delay. The time interval between both pulses of consecutive pulse pairs transmitted by the interrogator varies. For each interrogator, there is a unique rhythm. So the correct option here is alpha. The pulse repetition frequency of the pulse pairs transmitted is different for every aircraft. That is called jittering. Okay. Next, 52. The DME line of position is a circle with radius what? Slant range and center, slant range and center of the DAV station, ground distance, center DME, ground distance and center aircraft. So the DME line of position, nothing but this is, there is going to be a DME station right in the center, let's say. Okay, this is your DME station. Let's say you are approaching this DME station like this, like this. So where you are this much distance away from this DME station, it will give you, let's say, information of 5 nautical miles. Where you are this much away, the information will be 10 miles, and this much away it will be some 20 nautical miles. So this way, you can imagine that DME is nothing but the center of a circle, and the distance given by it is nothing but the radius. The radius. Okay, DME is at the center, and you are on the circumference of that circle, approaching the DME station or going away from it. Now we all know that the ranges given by the DME station are slant ranges, right? The correct answer here will be Bravo, but there can also be a chance that Charlie can be an option. A ground distance of which the DME is the center. Okay, so Bravo and Charlie are both correct options actually. What is the function of the eco protection circuit? Now, the function of the eco protection circuit, what is it? The eco protection circuit reason is, or the purpose is, to accept the very first reply pulse coming from the DME ground station following the shortest route. Okay, this eliminates any ground reflections or ground returns. So the correct answer is EPC has to detect if the interrogator receiver has been locked on by reflected pulse pairs. EPC has to detect if unwanted squitter pulses are interfering with well-functioning interrogator receiver. EPC has to detect if pulse pairs reflected by ionosphere are interfering. EPC has to protect transponder receiver against reflected pulse pairs. So the correct answer is option A. We all know the operation of the DME. The aircraft interrogator will transmit pulse pairs in the direction of the DME ground station. This DME ground station is going to accept those pulses, wait for 50 microseconds, and retransmit pulse pairs to aircraft. Okay, reply pulses back to aircraft. Okay, so it is important that aircraft locks onto this valid reply pulses coming from the DME station and not any other pulse or reply pulses coming from, let's say a ground object, meaning any ground reflection. So eco protection circuit is installed or designed to make to make sure that doesn't happen. Okay, to eliminate unwanted ground returns which are irrelevant. Next, during a flight at flight level 260, a pilot doesn't receive any DME distance indication from a DME station 220 miles away. The reason for that is what? Okay, so we all know that DME works on the principle of line of sight. DME works on the principle of line of sight range. Okay, the formula is range is equal to 1.25 square root of height of aircraft plus height of square root height of ground station. Now here the ground station height is not given to us. Let's assume it is at ground level. So range is what? 200, 220 nautical mile, 220, 1.25 square root of height 1, where height h1 stands for the height of aircraft. So root of h1 is equal to 220 divided by 1.25. 220 divided by 1.25 is 176. Now 176, so height 1 will be 176 square, that is 30,976 nautical mile, because 220 is nothing but 220 nautical miles. So the final answer will be in terms of 30,976 nautical mile divided by 6,000, which is correction, divide by 1 nautical mile is 6,000 feet. So 30, correction, 30,976 into 6,000 is range. Sorry. This final answer that you will get will be in terms of feet only. Okay, my fault. Will be in terms of feet, 30,976 feet. That is the height of your aircraft. Now, your aircraft is at flight level 260. So if I have to draw this diagram, your aircraft is at a height of flight level 260 or 26,000 feet. Here is your DME station on the ground, and your aircraft is 26,000 feet. The distance is 220 nautical miles. Now, according to this line of sight formula that we have applied here, when you are 220 nautical miles away from the DME station, you must be at least 30,976 feet above the DME station. Only and only then you will receive that DME signal, or you will be within the range of the DME signal. Okay, so that means your aircraft should be somewhere above this. Should be somewhere above 30,976 feet. Okay, above that. And now, as given in the question, your aircraft is below that level. It is at 26,000 feet, much below 30,000 feet. So therefore, the answer is, since aircraft is below the line of sight range or below the altitude for the line of sight range, it doesn't receive any signals from the DME station. So correct answer here will be altitude is too high. Aeroplane is circling around the station. Range is always less than 200 miles. Aeroplane is below the line of sight altitude. Correct option is option delta. Aeroplane is below that required altitude. 55. Aircraft is flying at flight level 180, 190 miles from a DME. Aircraft equipment fails to lock on. Why is this so? It's similar to the previous question. So let's erase this. So I'll write it here. So again, range is equal to 1.25 h1 plus h2. Range given to us is 190 nautical miles. 1.25 square root of height 1, where height of aircraft. Height of ground station is 0 because it's given here. It's located at mean sea level. So height h1 is 190 divided by 1.25, which is 152. So height will be 152 ka square, 23,104. 23,104 feet. So correct answer will be what? So correct answer will be aircraft is too low to receive the signal. Now aircraft must be at 23,000 feet high. Aircraft must be at 23,000 feet high, as we have found out here. But as given in the question, aircraft is actually at an altitude of 18,000. It is at 18,000 and the distance is 190. Okay, so if you are 190 nautical miles away from the DME station, you must be at 23,000 feet, not 18,000 feet. So you must be at least 23,000 or above that. So here aircraft is below that required minimum altitude. So therefore the option that I have selected is aircraft is too low to receive the signal. 56. DME is a radar type facility and its maximum range is limited by height of the plane, like we have seen in this question 55 and the previous question previous to that 54. Here airplane is below the line of sight altitude, and in 55 we saw that aircraft was again too low to receive the signal. So DME is based on the operation of line of sight range. You must be within the range of the DME signal to receive that DME facility. So your height of the airplane determines that. So correct option is Charlie. 57. Aircraft is at flight level 310 and it can't receive the signal from a DME which is 240 miles away. Why is this so? So again, let's apply that formula. Range is equal to 1.25 H1 plus H2. So range given in the question is 240 nautical miles. 1.25 H1. So H1 will be 240 divided by 1.25. 240 divided by 1.25 is 192. H1 will be 192 ka square 36,864. So that means your aircraft should be at least 36,900 feet above the DME station. But aircraft is below that altitude, it is at 31,000 feet. So diagrammatically, let's say this is your DME station and this is the range. This is the designated operational range. When you are 240 miles away, when you are 240 nautical miles away at a height of 31,000 feet, you will not receive this DME signal because you are below the specified minimum of 36,900 feet. When you are 240 miles away from the DME station, you must be minimum 36,900 feet in order to get those signals successfully. So if you are below that, you are not going to get them. So the answer is aircraft is not in line of sight of the DME delta. 58. The time interval between transmitted pulse and reply pulse is 120 microsecond. What is the range? So formula is range is equal to speed of light into time interval divided by 2. Okay. Now here the time interval given to us is 120 microsecond, is 120 microsecond, which is inclusive of 50 microsecond delay, because whenever you send a radio pulse in the direction of the DME station, it will receive that, wait for 50 microseconds, and then retransmit the reply pulse. So we will have to subtract this 150 microsecond delay, the waiting period. So your answer will be 70 microseconds. So now use this value in the formula. Range is 3 into 10 raised to 8 meter per second into 70 into 10 raised to minus 6 seconds divided by 2. So 1.5 into 70 into 10 raised to 2. So 1.5 into 70 is 105. this many meter or 10.5 kilometer. 10.5 divided by 1.85 is 5.7 nautical miles. The correct answer will be range is 5.7 miles or 10.5 kilometers. Select that option which is closest to this value. When aircraft is at flight level 360 and above the DME station, what will be the range shown? So when you are flying directly above the DME station, when you are flying directly above the DME station like this, okay, the information shown by the DME facility will be your slant range. Now you know that you are 36,000 feet above this DME station. 36,000 feet is nothing but 6 nautical miles. So the DME will show that the slant range is 6 nautical miles. But as a pilot, you very well know that you are not your slant range is not 6 nautical mile because you are directly above the station. So there is no concept of slant range, but still it will be shown as slant range to you. So remember, when you are directly above the DME station, the range shown by the DME is nothing but your height above the DME station. Okay, very important for your Viva. Aircraft is flying at flight level 430, 43,000, 25 miles away. What will be the slant range indication? So let's draw the Pythagoras theorem triangle. Here is your DME station. Here is your aircraft. Okay, you are 43,000 feet above, 25 miles away, and you have to calculate this slant range. So slant range will be equal to x square. 43,000 feet is nothing but 43,000 divided by 6,000, 7 nautical miles. So just write here x square is equal to 7 square plus 25 square. All the units must be same in terms of nautical miles. So 49 plus 625 is 674. So x will be square root of that, which is 26 nautical miles. So slant range is 26 nautical miles. That's it. So this concludes our lecture. I hope you have understood all the 10 questions, the answers I gave, the explanations. If you have any doubt, any feedback or anything that you need clarity on, let me know in the comment box of this video lecture. All the best. Subscribe to this channel, please. Share this video with all your friends who are preparing for the exam, and hit the like button if you have liked this video lecture. I'll see you in the next video in which I will be solving the next 10 questions. So I'll see you there.